All right, so continuing with related rates problems. A boat is pulled into a dock by a rope attached to the bow of the boat and passing through a pulley on the dock 2 meters higher than the bow of the boat. The rope is pulled in at a rate of 0.4 meters per second. How fast is the boat approaching the dock when it is 9 meters from the dock? Round your answer to 2 decimal places. Just kind of a quick reminder here. Unless WebAssign says round your answer to so many places, you need to put in exact numbers. Somebody had a problem that they put in 1.728 and the answer was looking for E minus 1. 1.728 is the correct decimal approximation, but unless they ask for, 2 decimal places or something like that, then you should really be putting in the exact answer. Oh, yeah, question?
Are we skipping G?
Yes.
Okay.
So, to kind of help you out here, let's take a look at a pared down diagram of what's going on. We've got a boat being pulled in along the surface of the water by a rope attached to a dock, and that dock is 2 meters higher than the boat. So let's call this side X, this side Y, and this side Z. And let's take a look at some of the information we're given here. Let's see. For instance, we know that y equals 2. So let me write down a few variables here. But y equals 2 is one of them. That's one that's given. 2 meters higher than the bow of the boat. The rope is being pulled in at a rate of 0.4 meters per second. Now the rope is going to be attached to the bow and to a pulley on the top of the dock. So that's actually a rate. We have to express it as such. Rope is pulled in at a rate of 0.4 meters per second. How would I express that? What calculus terms am I going to use to represent that?
Dx over dt.
Dx over dt? Almost.
dz.
dz by dt equals
You have to.
0.4 meters per second. But there's a mistake here. What's my mistake?
Negative.
It's negative. Because rope is being pulled in, that rope is getting shorter in length. So don't overlook the negative part there. How fast is the boat approaching the dock when it is 9 meters from the dock? So 9 meters from the dock. Let's see. What's that telling me? How can I represent that? X is 9. What's going to pull all this information together? This is going back to your question again, James. That is, sometimes you're going to have to come up with the equation. What equation is going to pull all this information together?
A squared plus b squared. X squared plus y squared equals z.
Yeah, the Pythagorean theorem. X squared plus y squared equals z squared. And if it helps you out, maybe put little brackets around all this, because we're going to have to differentiate it. And the key thing is we're going to have to differentiate implicitly. We're differentiating with respect to t. So d by dt. So try and pull this together. It's going to be the derivative of the outside. The derivative of the outside is easy. That's just 2x. But I hope you don't stop at just 2x. What more, Eli, do I need to put in there?
Dx by dt.
2 dx by dt. Awesome, thank you. And then a similar thing over here with the y's, right? It's going to be 2y dy by dt equals 2x, or 2z dz by dt. You can cancel out all the 2's if you'd like. It's not a bad idea. And come up with x dx by dt plus y dy by dt equals z dz by dt. So it seems as though I need a few more things. For instance, I don't have z. I don't have, let's see, well, I'm looking for dx by dt.
So we need dy by,
We need dy by dt, and they didn't give us that. But we do kind of know it, or at least can figure it out. Let's start out with how we're going to figure out what z is. That one you should be able to give me.
by doing the Pythagorean theorem.
Pythagorean theorem. Square root of 9 squared plus 2 squared is the square root of 85. Cool, we got rid of 1. Let's think about what dy by dt is. Can anyone tell me in words what dy by dt is? Wayne?
It's the change in the height as you approach it.
It's a change in the height of the pulley over the dock, or pulley over the level of the boat as we are approaching. What's that change in height? 0. Because it's a fixed 2 meters above the bow of the boat. So that's not changing. So if you take a look at this, of these 6 quantities, we know 5 of them. So we can fill in and solve the rest. We want to know what dx by dt is, but we know what x is. X is 9 dx by dt plus y, which was 2, times 0 equals z, which was square root of 85, times negative 0.4. And if we solve here, we're going to get dx by dt equals negative 0.4 times the square root of 85 over 9. And that's going to be in meters per second. You can come up with a decimal value if you need to from there, but that's an exact answer as far as it goes. Nice. The big thing to catch in this one is that dy by dt was 0. Nice. Let's try another similar example here. Example I. 2 cars start moving from the same point. One travels south at 56 miles per hour. The other travels west at 42 miles per hour. At what rate in miles per hour is the distance between the cars increasing after 2 hours? All right, so let's see. A nice little sketch of this can help out. Example I. So we got one car traveling south at 56 miles an hour, the other one traveling west at 42 miles per hour. So south, and then west. I didn't draw these wonderfully to scale, that's okay. So I'll call that my x, this is my y. And eventually I'm going to want to know something about z. One travels south at 56 miles per hour. South at 56 miles per hour. in words that use some calculus. Kyrillos. How would I express this? Not here today? Oh, darn it. All right. Anthony. How would I express this part right here? One's traveling south at 56 miles per hour. Which one?
dy.
This is a rate, so it's going to have to be dy by dt. It's going to be 56 miles per hour. The other one travels west at 42 miles per hour. So what's that one going to be?
GX dt.
It's going to be dx by dt equals 42 miles per hour. And what we're ultimately trying to find out is your dz by dt, the distance between two cars, how is that changing after 2 hours? So that's your dz by dt. So that one we don't know. dz by dt. No.
Very similar to the other one, I mean, it's a different
It's-
topic, but like,
It's very similar to the other one. There is one little difference here. They haven't explicitly given us X or Y or Z. We still need to know X, Y, and Z if we're going to solve this. It's eventually, and you're right, this does eventually boil down to the Pythagorean theorem again. But I don't know what X is, I don't know what Y is, I don't know what Z is. How am I going to find each of those? And I think I heard somebody whispering that earlier.
distance equals rate times time.
Distance equals rate times time. Distance equals rate times time. And in the case of x, dx by dt, that's going to be 42 miles per hour times 2 hours. So x equals 42 times 2, which is 84 miles. Y is going to be 56 times 2, or 112 miles. I still need to know what Z is, though.
So now you put a second there.
Where'd you get the 2 from?
Oh, it's traveling for 2 hours, right?
Yeah.
T equals 2 hours of travel.
So put the 112 and the 84 into the Pythagorean theorem to find what z squared is.
Yep.
Or z.
So Z is going to be the square root of 84 squared plus 112 squared. Let's see what that's going to be.
140.
Does it work out nice and even?
140.
Wow. Yeah. Square root of 19,600 is 140 miles. Beautiful. But I'm running into a similar problem that we had before. And that is, I don't have any place to plug in all these variables. What?
Maybe derive the Pythagorean.
Yeah. You have to do the derivative of the Pythagorean theorem again. Perfect. Thank you, sir. D by dt. And that ended up being 2x dx by dt plus 2y dy by dt equals 2z dz by dt. And now I've got everything I need to plug in here. I can divide out the 2 like we did before and get x dx by dt plus y dy by dt equals z dz by dt. And then it's just a matter of grinding it all out. One kind of small double check on our work. Do you expect dz by dt to be positive or negative? I gotta vote for positive. Yes.
Positive.
Couple votes for positive. Why? Why positive?
It's increasing.
It's increasing, right? It should be, I mean, as these guys are driving farther west and south respectively, the distance is gonna be getting bigger. So it should be positive. Let's see that it is. So x is gonna be 84 times dx by dt, which was 42, plus y, which was 112 times 56 equals 140 times dz by dt. All right, some big numbers here. Let's see what happens. 84 times 42 plus 112 times 56. That it? So 9,800 equals 140 dz by dt. And if I divide by 140, I end up with 70, would be dz by dt. What are the appropriate units for dz by dt here? Say again?
Miles squared per hour.
Just miles per hour.
Oh.
Yeah. Nice. Yeah.
Does it just
True.
happen to work out this way, or once we get Z, can we just divide it by how many hours they can drive?
Oh, yeah. No, that should always work that way, because you're doubling. When you found 140, divide that by 2.
That's a good question.
Are you counting miles or the distance?
I think it worked out this way this time, but I think if you were traveling for 3 hours, it might not have worked out that way. I think
Yeah,
it
because
was,
the driving with the 2, everything.
yeah. So I'm not sure I want to generalize it. I have to think about it a little bit more further. Because I'd hate to say, yeah, you can always do this and then find an exception later. So, yeah. So this one, unlike the last one, had something where the last one had a place where the derivative was 0. Not that I think I want to do another Pythagorean theorem problem, but I do have one here that I had set up. We're not going to go all the way through it. Ladder slides down a vertical wall at a given rate, blah, blah, blah. Graphically, here's what it looks like. Graphically, you've got a ladder. You're going to move this away from the wall, and as you do, the top of the ladder is going to move down the wall. So here's what it looks like, and make me look good, ooh and ah, ooh, ah, cool. Now, this is a Pythagorean theorem problem, so you're gonna have a dx by dt, a dy by dt, and dz by dt. So we'll do x is the horizontal, y is the vertical, z is the length of the ladder. Which of those 3 quantities is gonna be 0? dx by dt, dy by dt, or dz by dt? Gotta-
DY.
Got different opinions here.
I'm not very good at this.
I got 2 votes for dz by dt, 1 for dy by dt. Dean? Joe?
Wait, what was the question again?
Which one of these quantities? I'm gonna say x is the length along the x-axis, y is the length of the height and Z is the length of the ladder. Which one of the quantities in this relationship, dx by dt, dy by dt, or dz by dt, is going to be 0?
DZ by DT.
Why dz by dt?
Because the length
Because
of the ladder is.
changing.
Yeah, the length of the ladder is staying fixed, right? So its rate of change, dz by dt, would be 0. So that's the big thing to keep in mind about this problem. Let's determine a couple other things about this problem. Again, without doing it, is dy by dt going to be positive or negative? Negative. What about dx by dt? Positive. Because you're moving it away from the wall, so you're increasing the length in the x direction. Meanwhile, you're decreasing the length in the y direction. So there you go. Nice. Okay. Let's take a look at example J. A cylindrical tank with a radius of 3 is being filled with water at a rate of 4 meters cubed per minute. Meters cubed reflects the fact that it's a volume. How fast is the height of the water increasing in meters per minute? So, okay. Got a couple things to think about here. You've got a cylindrical tank with a radius of 3. It's being filled with water at a rate of 4 meters cubed per minute.
That's dr dt.
Radius,
Not dRdt.
no,
What's changing there?
it's distant, or
What's changing here? What quantity could I regard that as? dV by dt. Good, so that's gonna be your dV by dt. So let's do that, dV by dt. So that's gonna be 4 cubic meters per minute. That's a lot of water. Let's see. The radius is 3, so R equals 3. That's in meters. How fast is the height of the water increasing? All right, well, got another quantity here. The height of the water increasing. dH by dt. Great. dH by dt. dH by dt. All right, that's our unknown. Let me make that look like an H. But I don't have an equation here. I got nothing. So, well, we have to think about a tank. And what's the volume of a tank? I'm not talking like an M1 Abrams. I'm talking about, a cylindrical can kind of shape. And the thing to keep in mind is what happens when you're trying to find a volume. When you have a rectangle, the area is length times width. But when you extend that in another dimension, if you drag that parallel, then you've got a height, and the volume is going to be the length times the width times the height. So you're just accounting for that extra dimension. The same thing happens with a circle. With a circle, what's the area of a circle? Pi r squared. All right? But then when you try and find the volume of a can, you're adding another dimension, and that's going to be the height. So the reason I'm mentioning this is so that maybe you can remember how you can come up with a formula for the volume of a can. It's just going to be pi r squared times h. It's just that extra dimension. And that's what we need here when we're working through example J. So let's see. I'll write it up here. Volume equals pi r squared h. And let's make our life a little bit easier on us. R is 3, right? And that's not changing. So in our case, pi times 3 squared times h, or volume equals 9 pi h. It's important to realize that isn't changing because you don't want to have to worry about the product rule or anything crazy like that as you work through this problem. All right, so at least now I've got an equation that involves V. And I haven't used any calculus yet, so let's introduce some calculus by taking the derivative. On the left-hand side, I get dV by dt. Let's see. Josie, what's the right-hand side going to be when I differentiate this?
9 pi.
Yeah, 9 pi dH by dt. Thank you. And since I don't know what dH by dt is, let's put in for dV by dt, which was 4 equals 9 pi dH by dt, and solve. So I end up with 4 over 9 pi is my dH by dt. And that would be in meters per minute. Why is it meters per minute and not meters cubed per minute?
One-dimensional. Right?
Yeah, height has 1 dimension, not 3. Volume has 3 dimensions, that's why it's in cubic units. Area has 2 dimensions, that's in square units. Length just has 1 dimension. So it's going to be in meters per minute, not meters squared or meters cubed. Do keep that straight. All right.
Can you go back up a little bit?
Yeah.
Why is it 4 meters a minute?
Why is it? You know what? I left off a 9 pi here. 4, 9, yeah, 9 pi. Thank you. Yeah, let me write it a little different.
How do you come to know that V equals pi r squared h?
That was my discussion here. You take the area of a circle times the height, and that'll give you the volume of a cylinder, of a can. So V equals pi r squared h. You just take the area of the base times the height.
Okay.
Okay? I mean, you essentially do the same thing with a rectangle to get the volume of a box. Thank you. So that's a 9 pi. Yeah, let me write it again a little different. 4 over 9 pi meters per minute. That's a lot better. I think that's where we're going to stop. I got to give you a quick little break, and we got to work on 3.10. So call it a day here on this section.